In this screencast, we will be talking about how you can use Azure Stream Analytics with Cosmos DB and do some aggregation group by queries on the stream data and then save the materialized view back in Cosmos DB. So to have this whole thing working, we will be creating in this screencast this Azure function, which will be pushing the data to Event Hub. And this Azure function will be reading the data from change feed of Cosmos DB and pushing the data back into Event Hub. And from Event Hub, the data goes to Azure Stream, and we will be writing the SQL query to do the group by and then taking the result back into the Cosmos DB. So to have this screencast complete end to end, we will be writing an IoT emulator, a small C# code which will pump the data in Cosmos DB, and then we'll be writing the functions here using the Visual Studio, and then we'll be writing some SQL here in Azure Stream Analytics. So all these pieces will be shown in the screencast. So in this diagram, I have shown some extra component which we may not be going in depth in this screencast, but this is just to show you the power of Cosmos DB change feed and Azure function. Like this Azure function you can use to push the data to any queue, and any web job can read that web queue and can trigger any other processes. You can use a same Azure function to push this data to for a cold storage, Azure Data Lake, and there's a sky is the limit actually what all you can do once you get the data in Azure function, which is reading a Cosmos DB change feed. So to get started, let's go ahead and create first the Cosmos DB instance. So go to Azure portal, look for Azure Cosmos DB, create, give the ID stream demo, and let's choose the API SQL API. And as you can see, there are multiple APIs available. That's why we call Cosmos DB as a multi-model database. But now for this screencast, we are using SQL API. I'll leave the subscription as is. A resource group, let's choose a resource group. It's always a good idea to have your own resource group and keep all your applications together. It's easier to find them out. And let's pin this to dashboard, and let's create stream demo a Cosmos DB instance. Okay, it will take just few seconds before we'll be ready to use this. Okay, our Azure Cosmos DB account is created. As you can see, we get this message, and now we can go ahead and create a collection in this account. So here, new collection, database ID. Let's create a database called IoT, and a collection also can be IoT. Make it unlimited. A partition key, let's give a partition key called IoT ID, and throughput leave it as 1000, and just say okay. Here unique key, this is a new functionality added in a collection. You can define a unique key. Unique key is like a if you are having a collection which is having, say, a user information, so if it has first name, last name, and email address, so that can form a unique key which will protect your database by getting any duplicate data there. So if you don't want your user to have same email, you can define a unique key saying first name, last name, and then email, and that will throw an exception if you get another duplicate record with the same first name, last name, and the email. So that's where you will use the unique key. But for this demo, we will skip this part and we'll just create this collection called IoT with a partition key called IoT ID. Now, while it is getting created, okay, it's created, and as you can see, it's empty. Now let's create this part where we have this IoT emulator which are pumping the data into the Cosmos DB. So let's quickly take a look how we can write an app which will pump some data into Cosmos DB. So here's the application. I already wrote this application, but I will just walk you through. It's very, very simple. It's a plain vanilla C# console application. And what it is doing is, as you can see, we can ignore connection policy for a minute. Basically, this is used when you have your data distributed in multiple regions and you want to say what is your first preference, and if that region goes down, what should be your second preference. That's about global distribution, but let's skip that for a moment and think about how we put the data into the Cosmos DB. So if you see, we just get this collection name, endpoint, and auth key from our app config, which has nothing yet. We'll fill it up in a minute. But the code is here where it just says pump some data into the Cosmos DB. And I have a data class defined, which is saying that this class will have IoT IDs, latitude, longitude, car ID, and some temperature and a timestamp. So this is the class I define, and this is the data will be stored into the Cosmos DB. And what happens here is, if you'll see, I just new up one of the instances of this class and fill up the data values for each property. Like what should be the IoT ID? IoT ID, I'm just creating a random string out of A to Z. So, you know, my IoT ID will be AAA, ABC, and MNF. It's like that. IoT ID is created, and then some randomly I'm creating some temperature values, putting the timestamp, and taking this data, which is just an instance of my IoT data which I have defined, saying create document async. So this is come out of the client, and client is defined, if you see, it is defined as document client, which takes the URI endpoint, auth key, and connection policy. As you've seen, a connection policy we have defined at the start of the code. I will share all this code on the GitHub so you can download this and play with this. And this document client comes out of the document client library, which you can get from the NuGet. It's called Microsoft Azure Document Client. If you want to see it quickly, let's see, manage NuGet packages, install Microsoft Azure Document DB. It's 1.20, and Newton Soft JSON, just these two libraries you need, and that's how you will define the client. And once you have the client, then you can I have two supporting methods, which create database if not exist and create collection if not exist, which basically checks your database, and if it's not there, then it says create database async. And same for the collection, create document collection async. Now, before we can so this is as simple as that. It goes in a loop looking for how many documents I set to update, and it just creates those documents. Now, before we can use, let's find out these values. What is the endpoint? So if I go here and then go to the keys, and here are my URI and primary key and secondary key and the connection string. So let's see what I need. First thing, I need an endpoint, and the endpoint is, here's my endpoint. Copy that, put it here. auth key. Let's take this key. And my database is IoT, collection is IoT, and I'm good to go. Hopefully, I will just run this. As you can see, it just called this pump data method, which is async and which goes through a loop and update everything. On top here, nothing much is happening other than I defining connection policy. My connection protocol is TCP indirect, and then I just get call initialize method, which uh, gets all this database and collection and endpoint name. And if you'll see what it does, nothing but creates a client using the endpoint and auth key, and then call this supporting method that create the database and create the collection if they don't exist. So that's all. So now let's see if I run this and just make sure I am saying input 1000 documents low. So let's see. I run this and start running here. Okay, it is inputting the document because once the document is input, I display a star on the screen. Let's see here the database, IoT documents, and I can see my documents is loaded. So as I said, IoT is defined lat, longitude, car ID, temperature, and timestamp, and the rest of it is a system property. This is our data. Its ID is always appended by the system to give it a unique ID, reference ID, and self. These all things are very well defined in our documentation. E-tag you use to do concurrency control, and if you have any attachment, this is the timestamp. But this is the data which we are trying to insert. Now, once this data is inserted, let's go back to our diagram. Now, these IoT emulators are inserting this data. Now, we will write an Azure function which will capture the change feed from this Cosmos DB and push that data into the Event Hub. And from Event Hub, we'll go to Azure Stream Analytics. So let's create an Event Hub first, and then we'll go and create an Azure function to push the data to Event Hub. So let's go ahead and create an Event Hub. And creating Event Hub is as simple as create a resource and type here Event Hub and just say create. As you can see, it's pretty straightforward. Just fill up this whole pan, put the name, check the standard pricing. There are two pricing, basic and standard. As you can see, it's pretty cheap. It's 0.28 cents for per million of messages. So there are two options, basic and standard, and then you can choose your resource group where you want your this Event Hub to be there. So let's select that, and then you just say create, and that's about it. So I already created Event Hub, so I will not create another one, but this is how you will create an Event Hub. Let me show you the Event Hub which I already have. So this is the Event Hub which I already created, and as you can see, there is no messages yet, and as soon as we will write this Azure function which will start pushing the messages in Event Hub, we will see the data in the Event Hub itself. Now you can see the messages and throughput and request, how many requests are coming, but to see the data in the Event Hub, you have to write a consumer of these events in the Event Hub. And for that, we will be using Azure Stream Analytics, and that will help us to look into how the messages are inside the Event Hub. Okay, before we go and write this Azure function, let's quickly create an instance of Azure Stream Analytics also, and then we will go back to writing the Azure function. So far we have Cosmos DB, we have IoT emulator, we created the Event Hub, and let's create the stream analytics too, and before we jump into the code. So for that, let's go to our portal and just type here stream analytics, job, and say create. And job name, let's call it stream demo, and resource group, existing resource group, that's my resource group, and just say okay, pin to dashboard and say create. Okay, it's deploying. So you can see here's the stream demo, and this is the overview, and they already give you a small query. Now here we have to figure it out, what's the input and what's the output. So let's do a couple of other things also. So input will be my add stream input, will be my event hub. As you can see, there are other options. You can get the data from IoT hub or blob storage. So let's do event hub, which I have created, and input alias. So I have to give some name. My name is event hub, event hub from your subscription, and event hub namespace is already selected. Rafat event hub, use existing one, which I already have here. As you can see, I have event hub 1. This is my event hub. It's already filled up. Public key consumer group, we can leave it empty for now because it will take default JSON UTF, and event compression type none, and just say save. And as you can see, it's testing the input event hub, and if it's successful connection test, so it tests the connection. That's a good thing, so you will not be surprised later. And here we set the input. Now let's go, and so input is selected. Now let's do the output, but before we say where the output is, let's go to our Cosmos DB database, which we have created just now, and create another collection which will keep the output from the stream analytics job. So let's go here. So stream demo was our Cosmos DB account, and now let's create another collection here. So we already have an IoT, and we create another collection in database IoT. Collection ID is IoT, say stream. This will take the data coming back from the stream analytics back into the Cosmos DB. This part, group by. We will do the group by on the stream and save back the results into the Cosmos DB. So this is the part we are doing now. Create unlimited partition key, same IoT ID is my partition key, and it's called IoT stream, and save it. Now I created this collection. Let's go to stream and connect an output. Here's the output, and one of the option is Cosmos DB here. Output alias, I will just call it output maybe, and account ID is stream demo. That's my account here, stream demo, for my Cosmos DB. So that's the one we will use. And then account key is chosen automatically, and database is IoT, and collection name is IoT, stream. Just make sure. Oh shoot. Anyway, I gave the name Steam, mistyped it. Let's call it Steam itself, and I mistype it here too. Perfect. And ID we can leave it empty. This ID is basically talks about name of the field in the output event used to specify the primary key which inserts or update operations are based on. So if you don't have an ID, you can leave it, and when the data will be inserted into Cosmos DB, Cosmos DB by itself gives by default an ID to all the document. So let's see, save this, adding output. Now it's testing the output, that can it connect to the Cosmos DB or not, and let's see if there's any problem. Connection to output succeeded. Perfect. So this thing happened here. So my stream analytics 2 thing is set. Now I have to just write this query. I want to do the average on temperature, because as you see my data here, my data is having temperature and IoT ID. So I want to do a group by query, sum of temperature or average of temperature for 15 seconds. Okay, so let's see how we will write that query here. So let's write it like this. Into my output alias is edit query. So here my output alias is output, from my input alias is event hub. That's the alias I gave for the input and for the output. Now here I can write the query to do sum, or let's do the average of the temperature. So I can write select IoT ID as IoT ID and let's do average on temperature. As we seen that this is the data coming in into the stream analytics, and we can we will filter out some of the data in our Azure function when we will write it. So let's say as average of temperature. Let's get this thing out. So select IoT ID average temperature as average temperature into the output, and from event hub now let's write here group by IoT ID, and let's say we want to average it just for 15 seconds. You can average it for minutes and hours, but just so our demo can quickly work, we can say our tumbling window is for 15 seconds. So this is it. This is a very plain simple SQL query. In place of average, you can do sum and maximum, minimum. You can do a lot of SQL. If you just search Azure Stream Analytics, you will find what else you can do here with the query. You can in fact put functions also here. So let's just save this. So it is saved. And here I was talking about you can write your own functions, and then you can call these functions in the query. So you can read more about it, but for our this screencast purpose, this is our Azure Stream Analytics work is done here. We'll just say start, and then we have to write. I'll click start because it takes some time to start, like 30 to 60 seconds or so. But now here, as per this diagram, we are done with all this. Only thing remaining is to write the Azure functions. Now let's get to writing the Azure functions here. So okay, let's go and create this Azure function now. Say new project. let's call this lambda, and choose Azure function and say OK. Choose empty and just say OK. Now let's go ahead and say add new item and Azure function, and let's call this function stream processor. Okay, and then choose Cosmos DB trigger here. This will fill up later, and database name, okay, we can write here IoT, collection name is IoT, and just say OK. Now you can see there's a boilerplate code is written by Visual Studio itself, and this input is the parameter which will have all the documents which have changed in the collection. That's how you get access to the documents which were changing. This Azure function is reading the change feed of this collection, and that's how you will get all the changes here. I have a complete separate screencast on just how to write Azure function and change feed, where we go much in detail in all those things. But here our focus is how to use the Azure Stream Analytics with Cosmos DB. So I will quickly go over a few of the things, but if you want to know more detail about change feed and Azure function, you should look at my other screencast. I'll put the link below this video. So now let's look at the properties here. So when you are using Azure function, you have to be having access to the storage. So you have to get the storage keys which you have on the portal. So as I said, you can go to Azure portal and create an storage account and get the keys from there. Now I already have a storage account, so I will pick up the keys from there. But if you don't, it's very simple to create. We can maybe quickly look at it. So here, how to create a new storage. You come here, you just click new, and you already have as one of the popular items here. So you just click on storage account and you will be able to create a storage account here. It's very simple. Just put the name and all other information and then say create. Okay, as I said, I already have a storage account, so I will not create one, but I will just get the keys from here and will use those keys in my presentation. So here's the keys. I will copy this key, the connection string, and then go and put it in my this config file. So this is the one, and here's the another one. Now I have to add two more things. One is my DB connection. So it's defined, so here you have to have a comma and then DB connection string. So DB connection, and now let's get the connection string for my database, which is here, stream demo keys, and this is my primary connection string. Get that connection string, and here it is. I have to put, this is the Lambda function which is pushing the data into Event Hub also. So I need this connection and this connection also. So let's go add a Event Hub connection. event hub connection, and let's get the event hub information. So you will get this access key for event hub is here. It's called connection string. So you click here, and here's the connection string primary key. So you copy this, and then we can bring it back to our this application here and put this value here. We are set with all the values in our config file. Now let's look at this processor here, the code. Now the connection string setting, this we call DB connection. So let's call it DB connection, and database is this, collection name is this, and this way, and there's a lease connection name called leases. Let's go ahead. Okay, let's run this Azure function as is and see if it receives any data or not. So we can breakpoint here, and let's run it. Okay, there's error. Was unable to start. Enter the source collection IoT, or the lease connection leases does not exist. So let's create this collection called leases for this Azure function to run properly. So let's do that, and let's create another connection in the database called IoT. Collection name may be leases. Okay, leave it as fixed and just say okay. Okay, leases is created. Let's go back to our code and let's try to run it again. Here it's running, and it's now listening. And now let's go to our IoT emulator here, which we wrote, and let's pump in some data here. So data is getting pumped, and here I see, okay, so the input count 13, so we got the 13 records, and if you click you can see the value of these records. Perfect. So we have Azure functions. Okay, stop this thing. So we have our Azure function is running, getting the data, but we should do some more massaging here. One is we don't want to put the whole JSON into the event hub, because we are interested only the temperature and the IoT ID. So we'll just put two things and in the event hub. So let's make the changes for that. Now we already had a connection set up for event hub. So what we can do is we can write a code like this and remove this. Okay. So before getting into code, let's do some quick housekeeping thing here. Let it use event hub connection string builder is missing, and the reason is we have to go here to NuGet and get the Azure event hub. Microsoft Azure event hubs. So let's get this guy installed. It's taken care of. Okay, encoding here. So what's happening here? We are just getting the event hub connection, which we have set here. Get the event hub connection and create a client for event hub, and it's as simple as that. Just take the connection builder string, create from connection string an event hub client. How simple it can be. And I am going through the list of input doc, and parsing only the IoT and temperature and creating a JSON document and then pushing it to Event Hub, event data. And that's it. So this code is just going to push the data into the Event Hub. Let's save all this. So all these connection pieces are done. Stream analytics we started. Let's go back and see everything is okay there or not. Stream demo. So this is there, it's running. So you see start is dim means it's running and you can stop it. Our SQL looks good. Input and output is wired. And quickly look here. IoT stream, it's empty. There's nothing here. IoT should be empty too, because what I did is I set up a TTL. So every after 2 minutes the data is cleaned. So it will be good for us to do the demo so we can see if the data is coming. Now let's go ahead and run this function. So it's ready and listening. Now push some data into stream here. The data is getting pushed, and as you can see, it's getting processed in the by Azure function. It's pushing data to stream, and now let's go look at stream if everything is okay there, because if there's some problem you will get this warning sign. And this comes because it says, you have multiple rows and your partition key output contains multiple rows and just one row per partition key. It's just saying that you should be more efficient, but everything should be fine because it is the select statement is right, and I'm trying to push data back into my stream, IoT stream. Let's see if we get anything here. Yes, we are getting it. Good. So you see what's happening here. We are doing the average of temperature for this IoT ID every 15 seconds. So this is what is happening. We are grouped by doing the IoT ID for tumbling window of 15 seconds. How much is resource utilization is happening. And this is, I wanted to show the events. So quickly, yeah, look at this events here. You can see how many events are pushed. So all this happened. This is of the IoT emulator pushing the data in Cosmos DB. We wrote the Azure function, which is very simple. If you see, just after defining the database and connection and giving the string, we get all that as an input parameter to this method, and we just write the code what we want to do here. We don't have to worry about anything else. That's the beauty of this Lambda architecture, this Azure functions. And as you can see in my diagram, what I showed here, the same function can take some data and push it to queue. In the example, I'm pushing it to Event Hub, and then you can have much more, many scenarios can light up because of that. You can have another Azure function which is reading the same data feed and putting the data in Azure Data Lake. So there are multiple options, but I wanted to keep our focus on how you can use Azure Stream Analytics and do the group by and then keep the data back into the Cosmos DB. And I think in this screencast we are able to show that. And as you can see here, this average temperature, it shows different for different ID, and this is your materialized view for IoT data. And as I said, there are many methods are available in Stream Analytics. You can do much richer aggregation for your data. If you will search aggregation function for Azure Stream Analytics, you have a lot of options here: average, count, max, min, standard deviation, lot of analytics functions, array functions, many things you can do. And as you can see, it is as simple as writing a quick query here and just getting the data. Here's one more thing. You can test this query, whether this query is proper or not. When you click on test, you can upload a sample data, and then you can run this query to see if your query is right or not. Now, to do this testing, I have to stop the stream processing job, but it is as simple as that. You click on test here, and it says please upload a sample data, and that sample data can be, you know, a plain vanilla JSON document. It can be just like this. Here's my sample document. It's just a JSON with IoT, ID, and temp. That's it. So you upload that document here and do a select so you can see if your query is working properly or not. And as I said, they have a pretty rich logging, so you can find if there's any problem between all this. So in this screencast, you have seen how easy it is to integrate Azure Stream Analytics with Cosmos DB. And you also seen how you can write an Azure function which can push data to Event Hub. If you have any more questions, please send it my way. And let me know what other kind of screencast you would like to see. Let us know what other integration you would be interested in to have with Cosmos DB. Thank you for your time.